active. Sharp. So this is what we call the law of total, or let's just say the law of total linear momentum. So what this thing law basically implies, I'm gonna explain it loosely, is that like momentum, the total momentum before is equal to total momentum after collision or interaction. What do I mean by that? As an example, yeah, let's use moving objects. Let's just say I've got a surface there. Then I've got a tennis ball rolled in this direction. This is of mass 3 kg. It is moving at 2 meters per second. Then I've got another tennis ball. It is 4 kgs. It is moving at 5 meters per second. Let us take right as our positive. You can take whichever is your positive, but yeah. Now, these two in the opposite, these two meet and they hit each other, such that this one, this pink purple one changes direction. Thing is still the same, but it moves at maybe minus 1 meter per second in the opposite direction after they hit each other. Then this one moves still the same weight, doesn't change. Moves at 3 meters per second. Okay. No, they don't tell us. They don't tell us the speed. It moves in this direction, but they don't tell us the speed. Or they don't tell us, okay, now they don't tell us what, yeah, in this direction doesn't matter. They don't tell us the speed. So now, how are we going to calculate, ask us to calculate V final. Summary of the scenario, we're doing what we call the law of total linear momentum. It implies, loosely speaking, that momentum before, total momentum before equal to total momentum after. That is, when you add the momentum of this and this, before collision, it is going to be equal or the same as the momentum of this and this after collision. That's what this thing is saying. So now we've got the scenario where we've got a 3 kg ball moving 2 meters per second to the right. We take that as positive, and I have another ball moving in the opposite direction of mass 4 kg at 5 meters per second. They collide after collision. The 3 kg ball moves in the opposite direction at 1 meter per second, while the other ball of 4 kgs moves in the opposite direction at what speed we don't know. We asked to calculate the speed. This is how we're going to calculate the speed. Let's first find the momentum before, total momentum before. Total momentum, use a different color. Total momentum before will be equal to momentum of the first ball. So let's just get M1 and V1. That's just the momentum MV of the first ball, plus momentum of the second ball. Let's call it M2 V2. Okay, so our mass is 3 kgs. Velocity is 2 meters per second. We took our right as our positive. Our mass for the second one is 4, and then our thingy is 5, but it's in that direction, so it's negative. So this goes 6 minus 20, which is minus 14 kg meters per second. So that's the momentum before collision. Now, what is the momentum after collision? They have to be equal. Let's calculate the momentum of the collision. After collision, M1 V1 plus M2 V2. The mass of the first one is still the same. The speed is in the opposite direction, so it's minus. Plus, the mass of the second one is 4. The speed we don't have. We don't even know what the direction is. So, but since these two, momentum before equal to momentum after, and we also find V final of the second ball. So we're then gonna put here minus 14, including the sign, because the law has proven what momentum before collision in an isolated system is equal to momentum after collision. So we're gonna go minus 14 equal to minus 3 plus 4 V2. Take this to the other side, becomes a positive. Then it gives us minus 11. Therefore, V2 is equal to what is minus 11 divided by 4? Quickly. It is 2 point 6 Yes. 7.5, yeah? Negative meters per second. So what can you say? You can say that after the collision, this small one moved in this direction and the big one as well moved in that direction. Why? Because of the sign. Delicious, ne? Delicious, right? It's more delicious than your favorite meal. Yeah? Or not? Or partially delicious? Or not really there?